Welcome back to the Belzone podcast, your go-to podcast for all things engineering and coatings. I'm your host, Richard Bywater, and I will be joined today by our special guest, Mike Jones from Jones Marine Technologies, who will be talking to us about his experiences in applying applying surface-tolerant products underwater. So, what are surface-tolerant solutions? A surface-tolerant coating is a fluid substance that is applied to a metallic surface to help prevent corrosion. Surface-tolerant coatings differ from regular coatings due to their suitability on surfaces that have been prepared with a lesser degree of preparation than commercial blast cleaning. They're specifically designed for in-situ applications to damp, wet, oil-contaminated or even underwater surfaces. The idea came from the field, the oil and gas industry, in situations where grip blasting was either restricted or not an option. So a coating solution was needed which covered this type of scenario. This led to Belzone beginning to develop a surface-tolerant coating grade almost 20 years ago, back in 2003. So to discuss the practical application of this type of solution, I would like to introduce today's special guest. Mike, how are you doing? Pleasure to have you on. Are you okay?
I'm great, thanks. Yes, keeping busy and planning for our next works in West Africa.
Excellent. Okay. I know you have, just before we kind of started, mentioned the background. Are you liking our new studio? And
I think it's rather smart. Yes. I think I should do something like this when I build my new office.
Yeah. Well, actually, just looking at your background, I don't think it's too dissimilar, to be honest. I think we've got the same wood paneling, maybe.
No, this is a log cabin.
Okay. So where are you actually, at the moment? Are you
in Fordingbridge in Hampshire?
Okay. Nice.
Yeah, I work from this office simply because we work different time zones. I've got guys in Brazil doing design work, guys in Miami and Washington looking after process procedures, guys in Nigeria looking after site stuff for us, and me here in the UK trying to juggle.
Right, okay.
Keep it all going.
A lot of organisation, I can imagine. I think for kind of context, if you could just introduce yourself, your company, and just some of the type of work that you guys are doing globally at the moment.
Well, my company, Jones Marine Technologies Limited, we look after or work with companies who support the offshore oil and gas industry in Nigeria. We have done work in the UK and Angola. Okay. And what we are doing is looking after structures where they're starting to corrode, primarily replace coatings, fill corrosion pitting. And now we're getting to a stage where we're actually cutting out steel and replacing steel on FPSOs.
How long?
Platforms.
Yeah. Excellent. So how long have you been doing this type of work?
Well, if we go back to BP Angola work, we've been doing this for 10 to 12 years now.
Okay.
That's the offshore work. And if we go to work in the North Sea, we can go back nearly 20 years now.
Wow, okay.
We're concentrating primarily on the warmer climates because I don't like the cold. I really don't, and working in Africa is so much more fun.
Yeah, okay. So a lot of your work, obviously, we've spoken a lot in the past. I know you very well. You do a lot of underwater diving applications, don't you? And so I suppose the difference between work in the North Sea and the work in Nigeria is, quite noticeable.
Temperature makes quite a large difference when it comes to applying coatings. We've done some coating work or trials as well in Newfoundland and Labrador, where sea temperatures barely get above 5 or 6 degrees centigrade in the warmest time of year. And as with any paint, it doesn't stick well or even go off it's very cold, except for the new 5831 low temperature, which Belzona produce now, I think primarily because of what we did in Newfoundland.
Okay.
West Africa gives us warm 28-30 degrees C temperatures where paint goes on with the right training and experience. It probably as easily as putting a coat of emulsion in your lounge.
Excellent. Yeah, I can imagine the application process is a little bit different. But I'll tell you what, we'll touch on that in a little bit. So you mentioned a couple of the Belzona products there. Today's episode, we're obviously discussing surface tolerant products, and we've asked you to come on because you from a practical point of view apply a lot of these products in the field. You've got a very good experience, a wealth of knowledge, and many applications under your belt. So what has the use of surface tolerant products given you and your business and your customers?
What it's allowed us to do is to work in places where you would never normally consider applying an epoxy or even paint. Submerged wet surfaces in engine rooms where you've got heavily pitted areas, external hull surfaces which are heavily pitted, which need filling before painting. And we're currently using Belzona products of 1111 and 1161, which is a paste grade material for bonding steel plates, where we've got very thin areas on a vessel's hull, and on a couple of occasions covering holes in ships' hulls, which give us time to prepare and come back and cut out the shell plate and replace it. The coatings themselves, you really need to prepare the surfaces properly, as per Belzona's instructions. And when you set that plate on, don't expect to get it off, because our clients go, "Oh, Mike, will this plate come off with the water pressure?" There is, if it's prepared properly, absolutely no chance of that plate coming off. I go to sleep on board very comfortably, knowing that it's been stuck on with a high quality material.
So just to be clear, the process that you're talking about is all done underwater. So it's not as if the hull of the ship is out in dry dock. It's all kind of.
No, the ship's afloat. The hull's underwater. We prepare the surface of the vessel's hull around where the hole is. We take it back to bare metal. We may, if there isn't already a profile on the bare metal, we'll add a profile using a grinder or a bristle blaster type machine. To give a profile, we need a rough profile. A grinder actually works incredibly well for doing that process. You want a clean, ideally rough surface. Prepare the surface and apply the coating immediately afterwards. The longer you leave it in between preparation and application, the more difficult it is to get the coating to bond. And I'm not saying seconds afterwards, I'm saying 20 minutes, half an hour. And you wouldn't want to be sitting around for that amount of time after you've prepared any steel, even above water, before you put paint on it. You'd want to apply the paint straight or epoxy or filler immediately. But it applies underwater, I would say, as easily as it does on the surface. And in some respects, we have tidier jobs done underwater, because planning is critical when you're doing something underwater, getting things to people, mixing the right quantities, not over mixing. On the surface, you really have to watch out for people who mix too much, who slap it on, or underwater it's very controlled and very methodical. And we're probably as happy with our underwater plates as we are with our surface plates. But when you look at our underwater plates, they look perfect. The ones on the surface, there's always a little drip here and there, which just makes the job less sightly. Even when you use masking tape to prevent drips. So,
excellent.
But no, I would say both above and underwater, you're getting virtually identical results with the product.
So you mentioned it goes on as easy as well. Obviously, if it's done correctly and with a skilled applicator as yourself. What are some of the challenges in terms of the applications, or even just kind of extra considerations you kind of need to have when doing that kind of work?
Extra considerations of weather.
Right, okay.
Ideally, you want very little swell.
Yeah.
You can do it. We attach ourselves to the side of the vessel using magnets with a couple either side, which basically stop you. Well, the diver can just hang there without finning and trying to keep into position, so you can put effort into what he's doing on the surface. You scrub the product into the surface underwater as you do on the surface to ensure that you get right to the bottom of any pitting or to the bottom of the profile. The first coat of Belzona should always be scrubbed in these instances, and then a thicker layer applied over the top to build the coat thickness. Underwater, you can get oils and other things, contaminations in the water, silt and things, but you just have to live with that and design your repair around what you expect. If you're putting a plate inside a vessel where everything is perfect, you might go for a 100 by 100 plate. If you're doing it underwater, you'd go for a 200 by 200 plate. That way, if there is any contamination on the surface that you haven't noted, or your diver isn't necessarily as experienced as you would like him to be, but chances are that holes don't appear when you want them to.
No.
So always go for a slightly bigger plate. And you're going to mix a pot of product anyway, so you might as well use it.
Yeah.
And there's plenty in a pot of Belzona 1111 or 1161 to easily do a 300 by 300 plate.
Yeah. Excellent. So you mentioned kind of temperature being extremely important at the start. What type of range of temperatures can you work in with these products?
We have applied Belzona 5831 in temperatures down to 4 or 5 degrees centigrade.
Wow,
on underwater blasted steel plate.
Right.
The product goes on, it wets out well, it goes on reasonably well, but it's quite thick. Ideally, heat the product before you take it down with you, but it loses its temperature very, very quickly. It's ideally taken down warm because it wets out more easily the thinner it is. And in Nigeria, we're working in water temperatures around 30 degrees, but when you're working on the side of a vessel where there's cargo inside, the surface temperature can be 50 degrees centigrade.
Wow.
And there the product goes on incredibly easily and quickly. It even if you don't put a very smooth coat on, it flattens itself out because of the temperature.
Yeah.
We seldom ever get any sag, which is a benefit, I think, these products. Some materials I've used in the past you get sag in them. These products don't sag, which is nice. Where you put it, it stays. So it's easier to build up a thick coating where it's thicker in the middle than it is on the outside. So when you press home a repair plate, the material sort of oozes out and around the edges. So you've got a total 100% bonded surface.
Yeah.
We always paint the plate with the same product just prior to applying it as well. So both sides, the plate and the hull, has been wetted out.
So just for the benefit of everybody who's currently watching on our YouTube channel and seeing the visuals, but also if you are listening in an audio format, we'll make sure to make a little show note with a link to the video on YouTube. But Mike, you've provided or you've done a video with us in the past, which shows in great detail the types of applications that we're talking about here. And I think it was this the hull repair in Nigeria that you worked on using the surface tolerant coating that we've mentioned. I think 5831.
5831.
Yeah, but in fantastic visual detail, you can see exactly how easily this product goes on. So, why do your customers like using a product like this on their assets? What does it offer them in terms of value?
In terms of value, often we're painting large areas. It's not all corrosion. We're painting large areas simply because the existing coatings are delaminating. The anti-fouls come off. We've lost coat 3 on an international product. Not all these coats are put on properly when they're painted on ships in foreign ports. So we prepare the areas where we have corrosion. We remove all loose coatings down to something which just isn't going to come off with a great deal of effort. And that's where you leave it, because you don't want to take off paint that's stuck onto the side of the shell plate properly. So we prepare all the area, we prepare all the corrosion down to nice shiny metal, and then we apply a coating 5831 over the entire area. This way, one, it extends the life of the coating they've already got, which is very, very important, and secondly, they don't have corrosion spots which get deeper very, very quickly. A lot of these vessels in Africa and places, they have very limited cathodic protection. So as soon as you get exposed steel, you get excessive corrosion occurring. So you've got to pick these points up. You've got to fill the pitting, paint them, and you've got to build up the coating in those areas. Lots of the areas on the vessel where we've cleaned, the anti-foul is in perfect condition, but you get to some areas where, whoa, it's just coming off in sheets. So we just remove it all and put a coat of paint on. Oh, well, I do have a picture which I could show.
If you're happy to.
If you just, I'll just stick this one up a minute.
And
if I can remember how to do it.
Okay, so everyone kind of on audio format, I'll just describe this. This is, oh wow, yeah. So this is a picture of, I can imagine, is this you, Mike, or is this one of your dive team?
No, this is one of our guys painting, or you can see the top left area in that patch that the guy's working on. There's a fairly large area where it's corroded. You can work your way down to where he's working. There's a few patches above him and to the left. This is the primer coat on the vessel. The stripe on the right-hand side is where he has already applied a coat of 5831. We apply the coating at about 250 to 300 microns per coat. We apply 2 coats. We have found through experience that when the coating, and this is really painter speak, when the coating looks right, it's about 300 microns. When it looks a bit uneven, it's probably well under 250 microns. And then when it looks really very, very thick and ridgy, then it's over the 300. But if the diver uses his training and applies the coating correctly, we regularly use a wet comb thickness gauge to check the coating thickness, but with practice, after you've done that 10 or 20 times in your painting over an area like this, you know that you're going to have 250 to 300 microns of coating over the existing coating, which is well more than what was there in the first place. We always put a second coat on simply because it fills the troughs left behind. It's not a dead flat surface when we finish painting. And if it fills the troughs, then everything you're guaranteed to be well over 300 to 400 microns when you've completed the work, and that means all the thin areas the guy might leave. Nobody's perfect. So far, on all the work we've done, we haven't had any holidays.
Excellent.
Now that to me is a sign of correct preparation, application. The area you can see him painting at the moment, there was a lot of preparation to get rid of all that marine growth. That work there is about 6 hours work.
Wow. Okay. So again, just for everyone on audio format, it's a diver working on the hull of a vessel, and there's two quite large areas, square areas, where obviously the surface prep has been done, and yeah, you can really see the difference between the prepared areas and the non-prepared areas, if you like. One question I do have, Mike, and as again for everyone on the audio format, we will try and with Mike's permission, of course, see if we can get this picture in a show note. Good, the editor's nodding at me there. I've got that right. There are a couple of lines there that the diver has. One of them I think is the attachment that we spoke about before. But is one so? How would you physically get the product from the surface down underwater for the diver to apply?
Well, while we're painting, I would say small areas like this, where we're detailing corroded areas, we use a pot of product. We mix up about a litre of product, and it goes down to the diver in a small, what we use, if everybody knows, B&Q paint pots, where the applicator dips in. If we're doing larger areas where we can continually paint, we pump paint down to the diver using a pluricat, which ensures that he gets a fresh product out of the end of his through his applicator constantly. These areas are fairly limited, I would say, in size, and to paint that area he probably has about 8 to 10 pots of paint sent down to him, which as soon as one's sent to him, the guys start mixing the next one, which guarantees it's fresh. You can see on the diver on his left in this area, I'm not sure if you can see my pointer, we use a magnet which just clunks onto the hull. It's about a 200 kilogram holding force. There's a rope which is attached to him. There's also a second magnet to his left, so any swell he's kept in position. If he needs to push, and you can see the rope on the left is tight, it helps him locate himself. Running from the surface, there's a line which I'll trace with my pointer. This is what we call our down line. There's a shackle attached to it, which has got a little light line attached to it. So the bucket clips onto that. The surface pulls the old bucket up. The new bucket just slides down. Over on the left-hand side here is a hydraulic rotary tool, which we use to prepare the surface using a clean and strip, coarse grade. And that just hangs there. It's attached to the vessel with, again, a working magnet. These working magnets have got a little neoprene pad on the front of them so they don't damage the coating, existing coating and a newly applied coating. People worry this will fall off, but the hydraulic hoses are attached back at the dive vessel. But we haven't had anything come adrift all the time we've been working, doing this kind of work.
Excellent.
It works. The system works. Some divers come out with clean hands. Some divers come out and you look at them and you think, he needs a little practice. But at the end of the day, some of the guys get in when they're painting and you're shocked by incredible performance and quality of their work. Some divers don't paint quite as fast, so we slowly build a team of guys who are very, very competent.
Wow. So you mentioned the team there. How many would be in a team for an application like this?
We have a 9-man team to do this work. We work to offshore using IMCA standards. So we're well equipped diving wise. We're well away from the shore. We're offshore. We always have 2 diver medics on board, decompression chambers on board the vessel we're working on. We actually have a fully qualified doctor as well, and a small hospital bed, theatre, whatever. So we're well equipped working offshore. We have a crew supporting us of about 16 people who look after all the guys' daily needs, mooring, managing the vessels. It's a very, very well run system, and we even have internet, so you can keep close contact with your family and friends at home all the time you're working away.
And just, you know what, it's not the most coating or engineering related question, but I'm looking there at some fantastic blue ocean. Do you encounter much wildlife? Or I say wildlife, I think you know what I mean.
Yes. When you actually look at the vessel, when you're swimming down to it, there's almost a halo of fish, a foot to 2 foot away from the coral, which is growing on the vessel. Occasionally, our divers will look. There's a barracuda looking at me, and these things are 3 or 4 foot long. They like shiny things. We try not to have shiny things hanging on the divers. When we're using our rotary tools, I think things are interested. They're not hungry. There's so much to eat already in these waters. but the water visibility is stunning. It's you can see for hundreds of feet. I'll just pull up one.
Oh yeah, please do, Mike. Yeah. Okay. Wow.
Demonstrate some of the clarity of the water, and you can see our straight edges. I like to keep top and bottom. We tend to follow weld lines. Gives us the opportunity to check coatings on welds as well, which is also important.
Brilliant.
And one more for seeing the diver magnets. There's a few bubbles in the water. We have a bit of swell this day. One thing with the Belzona, the 5831, it's not a very runny product. So even if you have it in a pot, it doesn't spill or come out or fall out if the bucket tips slightly. If you held the bucket upside down, it would slowly come out. But thankfully gravity prevents that when it's hanging on a rope.
So it reacts. Well, I mean, it must be fit for purpose if you're putting it in a bucket and then applying it from that underwater. But yeah, so it remains nice and quite viscous, kind of.
Yes, you get a pot life of about 20 minutes, 20 to 25 minutes. Then you get to a point where you go, oh, finish with this, I want a new pot, because you might have taken longer to do something and you thought you can feel the product starting to go off. And as soon as you get to that point, it's discarded, it's returned to the surface. The pots are actually left so that the product cures in them. We don't try cleaning the pot out. When it's cured, you just bang on the bottom of the pot and a lump of paint falls out. You've got a clean pot to start the next day with.
Excellent.
So we try to be, and the product that was in the pot is now, it doesn't get thrown over the side, it gets taken ashore for proper disposal. But when it's Belzona products, when mixed, aren't environmentally hazardous.
No, so we kind of touched on the value you can give to your clients by using this. What would be the alternative for them to do a repair such as this?
The alternative to what we're doing is catastrophic to a business almost. We've got a vessel. This is a small vessel. We're working on production rates, probably only 1 million barrels every 7 weeks or 6 to 7 weeks. To take this off station, to take it into a dry dock, to completely repaint it, you'd have to disconnect all your risers, your mooring systems. You'd be out of production for probably 3 to 4 months. Yes, the vessel would go back in and you wouldn't have to do any work on it for the next 20 or 30 years if you put a good coating on it. But our costs for what we're doing is a fraction of the productivity costs of or the money that the vessel makes, and to keep that vessel afloat. And if we keep, as we do on other vessels, looking at just the small corroded areas, and we're also there looking after sea chests as well to keep inlets and outlets on the vessel clear, repairing any corrosion that we find on the inlet grills. This allows the vessel to stay on site for probably another 30 or 40 years.
And is the vessel online when you're doing this work as well?
The vessel is continuously producing product. This is an FPSO, so it's a floating production and offload vessel. Oil comes up from the wells. The gas, the oil, and the water and debris is separated from the oil. All the time we're working, so the vessel is going up and down in the water by 16 or 17 feet. So your water depth, I mean, this area will be near the water surface when we start the job, and as you can see, the diver's feet are resting on the bilge keel, and this area will be 17, 18 feet when the vessel's fully loaded. So no, the vessel doesn't have to stop work. We continually work all the time the vessel is producing. Occasionally we have to stop work if they have to off gas, if they flaring off excessive amounts of or burning off excessive amounts of gas. We get occasions when supply vessels come alongside in the area we're working, so we have to disappear for an hour or so. And when we're taking on fresh water or stores, we tend to pull away. We don't like working anywhere near where a vessel is using dynamic positioning. In fact, we don't dive at all when a vessel is using dynamic positioning. Our dive vessel moors alongside the FPSO against fenders with bow and stern mooring ropes. She's comfortable and allows us to dive all day without any problem. We can go back to the mother vessel for meals, or the FPSO lowers down a basket with the diver's lunch in it. So we're catered for very well. But at the end of the day, we're all here to do one thing: is keep this boat and vessels like it afloat with the minimum of interference to the daily processes that would normally happen when we're not there.
Excellent, because I think it's an important point that you mentioned. It's the alternative option you're weighing up against that kind of downtime, the cost of the downtime, the cost of the lost production, which, you know, compared to your repair method, by the sounds of it, is fractional. So,
well, it would run into hundreds of millions, and some of the vessels are producing 1 million barrels every 2 or 3 days, and we work on those. So it just can't be considered. Taking the vessel out of production just can't really. Well, it can be considered, but it would be catastrophic to business, whether you'd even get a well started again. No, we're here to keep these boats afloat. We can cut. If that was a totally corroded plate below class thickness, we can organise to have that plate cut out and replaced. We also do that work. So we'll do shell work, shell plate inserts. And again, all those plates, all the welding that would be done would need to be protected with Belzona as well.
Great. Mike, before we kind of come to the end of the interview, one thing that we like to do when we get someone like yourself on is just find out if you have any particular memories, any particular applications that stand out when you've been using Belzona products that you feel, you know, is worthwhile mentioning, or, you know, particular fond memories.
Some I won't mention, but I can't.
Okay.
We also do work. We also do work for the military defence.
Cool.
So they were fond memories.
We won't mention that. Don't worry.
But here we where a client has actually said to us, "Oh, we need to remove this and get rid of this now, or we need to replace all this steel work for like inlet grills." These vessels don't steam along. They don't need the impact resistance to inlet grills that a vessel that's doing 15 knots does. So where we have badly corroded or inlet grills, we actually use the Belzona 1111 to build up the thickness of some of these members, and the client's like, "But Mike, you could have changed these." And I'm going, "Well, have you ever tried getting one of these grills out when it's underneath a vessel? When you actually don't need to, you can prepare it back to bright shiny steel, build up the thickness. You have now stopped corrosion, and you've now got a grill which will last you another 20 years. And it's taken a day.
Yeah.
It hasn't taken 2 days to get the grill out, a day's worth of welding with hot work permits and everything on board, and another day or two to reinstall and change all the bolts." So there are huge savings to be made. Now, yes, changing the grill would be much better for us financially, but the way we do our work is we look at value to customer. We have to demonstrate that what we're doing provides the most economic way of doing the work, and by doing this, it gives us so much more repeat work. The guys we have on board painting at the moment are still there. We're doing other work. We've been on this vessel for nearly, for quite a few years now, and it's ongoing maintenance. And our only interest is in keeping this vessel in prime condition, because in doing that, it just generates work for us in a lot of other areas. Because we're giving this client good value for money, and all he can say is, so far is good things about us. And we haven't, to me, the grill example just, it was 3 hours work, I think, to prevent possibly a week's worth of work. And in Africa, finding the right steel to replace all your bars is not the easiest of thing. And Class were quite happy with just building up thickness with a product which has far more durability than the steel will ever have.
Excellent. About working smart.
It's I suppose you could look at it that way. It's having one of those. It's nice to be able to work when at the end of the day you can go, I really have looked after the customer.
Excellent. Mike, absolute pleasure. Thank you so much for giving us a bit of an insight into the work that yourself and Jones Marine. I'm sorry, it is Jones Marine, isn't it? Sorry.
Jones Marine Technologies. Brilliant. Everybody refers to us as JMT. In Nigeria. Well,
thank you very much for giving us a bit of an insight into the work that you do and the work that Jones Marine Technologies does as well. It's been excellent, and I hope you've enjoyed it.
Yes, I have. Thank you. And should anybody want any support, we're not necessarily going to offer you our services because we are quite busy. But we're always there. If you have a problem on site, if you have a question to answer, go back to Belzona, and if they can't answer it, they might come to me, and I'll be just as happy to assist in any way whatsoever.
Mike, thank you very much.
Oh, great.
Well, that about wraps it up for today's episode. We hope you guys have enjoyed it. Please remember to like, follow or subscribe so you do not miss out on any future content. You can find us, as always, on Google Podcasts, Apple Podcasts, Spotify or YouTube. If you want to get in touch with questions, feedback, or alternatively even, If you want to put in suggestions for future episodes, you can now do so on our new email address, which is podcast@belzona.com. Any questions on anything we've discussed today or anything Belzona related in general, you can go to our website, www.belzona.com. And finally, just want to say thank you very much to our guest today, Mike Jones from Jones Engineering. And yeah, thank you guys for listening. Look forward to seeing you next time.